Now, how are we going to use these properties to expand and condense? So it's actually really easy. When you see something that's multiplying, you will break it up with addition. When you see something that's dividing, like the big bar, division, to divide is to subtract when you use our exponent songs. And then anytime you see a cute little power, you just drop it down front. A power to a power, you multiply the powers. Put it down front and multiply. So when you see this is actually pretty quick and easy once you get the hang of it. It's not that complicated. So let's talk about this what we see. So if it's in the numerator, we've got log base 7 of 3x squared. And then we have to the denominator. Denominator means subtract. So we have log base 7 of 5y cubed. If it's in the numerator, it gets a plus because it's really multiplying. So this one would be log base 7 of 3 plus log base 7 of x squared. If it's in the denominator, because this whole thing was in the denominator, it gets a minus. It's like you're distributing the negative to each component. So you've got subtracting log base 7 of 5 and subtracting log base 7 of y cubed. If it's in the numerator, you're going to add when you break it up. If it's in the denominator, it's really being divided, so you're going to subtract when you break it up, which is why both of those things get to have the subtraction symbol. So then, all we have left, a power to a power. Any cute little exponent, all you're going to do is drop it down in front of the logarithm of the variable it's attached to. I want you to notice it didn't get to go in front of the 3 or the 5 because they're not what is being raised to the second or to the third. It's the x and the y that are being raised. So our final answer, positive log base 7 of 3 plus 2 times log base 7 of x minus log base 7 of 5 minus 3 times log base 7 of y. That's a 3. That is called expanding. So there's expanding and there's condensing. So expanding is breaking apart using those properties, and condensing is putting it right back together using those properties. So when you see addition, that means you're going to multiply when you put them back together. When you see a number in front, you're going to have to put it back up top where it came from. And then if you see subtraction, that means it's going to go in the denominator. It's going to be divided. So when you put this back together, let's see, we've got the natural log. And I want to remind you, natural log is just log base e. It's not a big deal. It's with the base is 2.71828. You still treat it the exact same as all the others. So you've got the natural log of 8 plus, and I know I might do a curly n to show natural log. It doesn't really matter as long as it looks like an ln. It's not a problem. So I've got the natural log of 5 squared, which would be 25. I'll write that down in just a minute. So we've got the natural log of 8, the natural log of 25, that's the 5 squared, and the natural log of 10. So whenever you add them, they're multiplied. And I believe 8 times 25 is 200. And now when you subtract them, they're divided. So our final answer, our condensed final answer, is the natural log of 20. I just want to take the time to honestly to prove it. Because natural log is base e, the calculator is programmed to handle this. Now, you can't, we also, really the truth is we don't have any variables right now. All of these have actual numbers, so I can totally prove it. This guy up here, I can't prove because it's got variables and we don't know those are unknowns. So here's what I want to prove to you. Did I condense this definitely down correctly back to natural log of 20? Let's find out. So when you type this in, you've got your natural log, and I'm just going to type whatever it originally said. It was the natural log of 8 close off the parentheses, plus 2 times the natural log of 5, close off the parentheses, minus the natural log of 10. And your 84s can do this just like your Inspires. There's nothing weird about it. There's a button on the side of the calculator just like this one right here. Boom, that's that number. Well, I just told you that that was the same thing as the natural log of 20. Oh, look at that. They match. Fabulous. Okay, the last piece of this, and we're super close to finishing. I know you've been probably tired of listening to me talk. So, a long time ago, you, especially when I was in high school, I had to do the change of base formula. So you have a calculator like the Inspire or the 84, most likely. So the 84, that is when you do, man, I hope I'm right, because I think I'm doing this from memory. I forgot my calculator up at school, so I can't check this right now. That is Math Alpha Math, and that gives you the cute little logarithm you can just type in. You could just type in the 8, type in the 24, hit enter, and it gives you the correct answer, the correct logarithm, the correct exponent for what you're doing, because that's log is bay. Remember, so that's equaling an exponent. Well, if you have an Inspire, like we have, okay, at least on my calculator, on my computer, then that was control 10 to the x. And then you could type in your 8 and you could type in your 24. Apparently the answer to that is 1.528. Well, when I was in high school, I had an 83. Some of you actually might still have an 83, and nothing's wrong with that. It's a good calculator. But I will tell you, it doesn't do the Math Alpha Math. It doesn't do the Inspire, control 10 to the x kind of thing. So you have to manipulate it. But doing that is not difficult. Your numbers, your 8 and your 24, they just become this guy over this guy. So the change of base formula changes the logarithm to base 10 so that it can be evaluated. It does it something that it understands, it knows. So when you're doing this, all you have to do, I call it log of the big. Now I don't mean numerically big. I mean that that's big in size and that's little in size. So log of the big over log of the base. So if you have an 83 or if you have an older 84 and it doesn't have the updated operating system that can do Math Alpha Math, then you still can evaluate these logarithms easily. So log of the big over log of the base. Let me prove it. We just determined that it was going to be 1.528. So if I were doing that in your calculator, now if you have the 83, remember whenever you hit just plain log, it does it automatically to the 10. So that, you wouldn't even see it on an 83. Now we have to do that because we're programmed to actually have to put in the base for an Inspire. So then this would be log of the big, log of 24. And I just realized I need to make a stacked fraction. Beautiful. And then that would be over log of the base. The base was base 8. So that would go there. Now remember, you're making it into the same base, the common log base, the base 10. Ah, look at that, 1.528. So this is super unnecessary. It's only for kids that have 83s, which is very few of you. So most of you will be just doing this one right here, log base 8 of 24. And but I just want you to know it's possible to do a different way.